Yo, welcome back to another video of Learn APCSA. Today's topic is we're going to be covering topics 3.1, 3.2, and 3.3. 3.1 is all about representing the design of a program by using natural language or diagrams. 3.2 is all about explaining the social, ethical, and implications of your program that you create. And then 3.3 is to develop code to designate access and visibility, constraints to classes, data, etc. So let's jump right into it. Okay, 3.1 is all about representing the design of a program by using natural language or by creating diagrams to indicate the classes in the program and the data and the procedural abstraction found in each class by including all attributes and behaviors. Now, that's the formal definition that is written in the APCSA course exam description and everything. But let's break that down. That was a lot of words. So, abstraction. What is abstraction? Abstraction is all about capturing the main idea specifically. You don't want anything irrelevant when abstracting ideas. Like Vade, he's not relevant for your problem that you're solving, right? So you only want to get the main idea. Data abstraction is separating what a data type is versus how it's implemented. And this is what classes and ADTs are all about. All they would do is separate what the data type is against how it's implemented. And then an attribute is just a variable in the private instance field of a class. The private instance field is at the very top of your class, and it has every attribute that the class will have. Maybe if you're making a hero class, then you could have an attribute of health points, int health points. And then procedural abstraction is like a black box. In this case, all you do is you call a method based on what it does, and you don't know how it does it. All you know is that, okay, this method does this. Such as, let's take a method called int sum. We know that sum will always get the summation of numbers that are provided into it, but we don't know how it does it. It's kind of obvious how it does it, but we don't know how it's done, right? And changing that internal code does not break any other part of the program as long as the signature of the method, so how it was declared, remains constant. And then method decomposition is breaking a big idea into multiple little ones. So again, let's say you have a hero class, right? Now instead of having one method that does tracking his health points, that tracks his damage taken, his weapon damage, all of that, you can have different methods for all of it. You're decomposing the method. And the best way for you to make your program as efficient and as the best like it can be is by using parameters for generalization. Parameters make methods reusable and available for different inputs. So like let's move away from the hero. Let's say we have a keyboard now, right? Like we're making a keyboard. One method could be to make a key. And now there's so many keys that you need to make in the keyboard. So the method could just take an input of a letter or a key, like a Unicode key or an ASCII value key, and then just make the key with it. And now you don't need to have so many methods saying make number 1 key, make number 2 key, make FN key, so on and so forth. And the best way for you to implement this is by planning out your program before you write it. Planning out your program will be super helpful anytime you're programming, whether it's for a competition, whether it's in your AP exam. Always understanding what the program is and then planning it out is always going to be super helpful. Okay, now on to 3.2. 3.2 is a little easier, I would say. It's not as vocab heavy as 3.1 was. So 3.2, like I said earlier, is all about explaining the social and ethical implications of a computing system, right? Again, I read that straight from a definition, and now let's break it down. So the first thing that we need to know is what system reliability is. System reliability is all about your program doing what it's intentionally supposed to do. If your program doesn't work under the stated conditions it's supposed to, there's no point for it. What the program is supposed to do under those stated conditions, without fail, without crashing, without bugs, without any of that, it means it works reliably and it works. So basically if your program works, then it's reliable without any bugs or crashes. Now, programs can have impacts on society. So you might make a program that helps solve a problem or fill a need, but it might create unintended effects on society, the economy, or culturally. Your program will have an impact. So, positive impacts are maybe improving efficiency, saving time, etc. Now, an example of a good thing that has unintended side effects is GPS. GPS allows you to go anywhere that you need to go. However, it does create traffic if a lot of people are trying to go in the same place. And programming can also have legal issues. So, programming can have legal issues because a lot of programs or a lot of code is available for open source, right? But because of that, some code might require you to get a license, purchase it for use, or stuff like that. And if you use it in your code without getting that purchase, getting that license, getting that permission, there might be some legal trouble. Maybe if you want to use an API in a terms of service, then you might need to get permission or just stuff like that. Otherwise, any code that is available open source that is not blocked behind any of that is available for open use. Now, topic 3.3 is a little bit more about programming again. Okay, topic 3.3 is to develop code, designate access to visibility constraints to classes, data constructions, and methods. This is all about either hiding data or making it publicly available in your program. And that's where the term data encapsulation comes in. Data encapsulation hides data using keywords such as public or private, with public allowing access from other classes or private keeping it encapsulated. And classes are designated as public and declared as a class. So whenever you make a class, it's always made as public and used and declared with the word class. Instant variables belong to the object, and every time the object is made, it has its own copy of the variables. So if you make 2 keyboards, then each keyboard has its own instance variables. They don't relate to each other, unless they're static. But attribute access should be kept private as well. You don't want something else, you don't want your second keyboard affecting your first keyboard, right? Those are separate products. And methods can be public or private. Private is internal to the class, and then public is available internally or externally. It just depends on what your program needs to accomplish. Thank you for watching this Learn APCSA video. I hope this helped out quite a bit. And yeah, over to you.